Yes. Students, now we start with the next topic, the inverse of a matrix. How we can find out the inverse? We already find out the adjoint of a matrix. Yes. So, to find out the inverse, let me suppose that A is a square matrix of order n. A is a square matrix of order n. Then and we already done that any matrix multiplied by its adjoint, that is always equals to determinant of A into I. If the determinant of A is not equals to 0, therefore A is known as non-singular matrix. Then A is known as non-singular matrix. From this part, now in the left hand section, left hand side multiplied by A inverse. Left hand side is multiplied by A on both sides. Because the determinant of A is constant, so therefore left cancellation, A inverse into A, adjoint of A equals to determinant of A into A inverse into I. Any matrix multiplied by the unit matrix, then we get the matrix as it is. So again, A inverse into A, adjoint of A, determinant of A into A inverse. And the second part, any matrix multiplied by its inverse, then we get the unit matrix. Any matrix multiplied by its inverse, A inverse into A, I into adjoint of A, determinant of A into A inverse. Any matrix multiplied by unit matrix, then we get the matrix as it is. We get the adjoint of A. Then how we can find out the inverse? A inverse is always equals to adjoint of A divided by its determinant. So how we can find out the inverse of a matrix? Inverse of a matrix is always written as adjoint of A divided by its determinant of the A, and it is necessary determinant of A is not equals to 0. If the determinant of A is not equals to 0, then the matrix is known as non-singular matrix, and if the determinant of A equals to 0, then the matrix is known as singular matrix. If the determinant of a square matrix is equals to 0, then the matrix is known as singular matrix. For example, find the inverse of the square matrix A, whose elements are 2, 3, 1, 4, 1, 3. So first of all, we check whether the matrix is singular or non-singular. So determinant of A is simplified, then we get 3, which is not equal to 0. Therefore, A is non-singular matrix, and every non-singular matrix is inversible. So after this, we find out its adjoint of E. And again I repeat, in 2 by 2 matrix, how we can find out its adjoint? To find out the adjoint of the 2 by 2 matrix, interchange the diagonal elements 2, 3, 3, 2, and change the sign of the known diagonal elements -3 and -1. That is the adjoint of E. And what is the inverse? Adjoint of A divided by its determinant of A. Determinant of A is 1 by 3 into adjoint of A. Adjoint of A is this. This is the inverse of the matrix. Similarly, one more question is find the inverse of the matrix of order 2, 3 by 3. Find the inverse of the matrix A, whose order is 3 by 3, whose elements are 1, -1, 2, 2, -1, 0, 1, 1, 2. So again, if we find out the inverse of any matrix, first we find out its determinant, or we check whether the matrix is singular or non-singular. So we find out the determinant of A, simplified, which is equals to A, not equals to 0. Therefore, the matrix is non-singular matrix. Then after this, we find out the cofactor of each element. Cofactor of 1, this into this minus this into this, -2. Cofactor of -1, 2 2s are 4, -0, and 1 2 is already negative. Cofactor of 1 3, 2 1s are 2, minus plus 1 3. Similarly, we find the cofactor of second row as well as the cofactor of third row. Then what is the adjoint of A? Adjoint of A is always equals to transpose of the cofactor of the matrix. So first row, the cofactor of first row -2, -4, 3. Cofactor of second row 4 0 -2. Cofactor of third row 2 4 -1. And its transpose. So in case of transpose, first row is changed to first column, second row change into second column, and third row change into third column. So after this, how we can find out the inverse? And the inverse of a matrix 1 by the determinant of A multiplied by its adjoint. A inverse equals to adjoint of A divided by its determinant. Determinant is A and adjoint of A is already this. So we find out the inverse of the matrix. One more question related to this. Find the inverse of the matrix A whose elements are 1 3 3, 1 4 3 and 1 3 4 and verify that A inverse into A equals to I3. I3 is the unit matrix of order 3. Or in other words, we already proved that any matrix multiplied by its inverse, that is always equals to the unit matrix. Any matrix multiplied by its inverse, that is equals to unit matrix. And how we can prove it? By the same condition, first we find out its determinant value. We expand it and determinant value of A is 1. So therefore A is non-singular matrix and every non-singular matrix is inversible. We find out its inverse. By the same condition, first we find out the cofactor. Cofactor of first row 7 minus 1 1. Cofactor of second row minus 3 1 0. Cofactor of third row minus 3 0 and 1. Then how we can find out adjoint? Adjoint of A. Cofactor of first row 7 minus 1 minus 1. Cofactor of second row minus 3 1 0. Cofactor of third row minus 3 0 1. Transpose this. So again, what is the inverse of A? Adjoint of A divided by its determinant. And the determinant of A is already 1. Then its inverse is this. And for the verification, you take the left hand side. Left hand side A inverse into A. A inverse is this. And A is the matrix this. Now we multiply these two matrices. And how we can multiply? First row multiplied by first column. 7 into 1 minus 3 into 1 and minus 3 into 1. First row multiplied by second column. 7 into 3 minus 3 into 4 and minus 3 into 3. First row multiplied by third column. By the same condition we find out the multiplication of these two. 7 minus 6 1. 21 minus 21 0, 21 minus 21 0, minus 1 plus 1 0, minus 3 plus 4 1, minus 3 plus 3 0, minus 1 plus 1 0, minus 3 plus 3 0 and minus 3 plus 4 1. That is the unit matrix of order 3. Therefore we write on I3. It may be written as I. I is the unit matrix and I3 is the unit matrix of order 3. Is it clear? These are the questions how we can find out the inverse. To find out the inverse, there are two methods to find out the inverse of a matrix. This is the first method by using the adjoint. Adjoint of a matrix, we find out the inverse of the matrix. Okay.